Hello, hello. Good morning, everybody. Good morning. I know there is a time in night. In night. Good morning, everybody. Good morning, everybody. In, in night, I have to study. In, in, in night, I have to study. In
There
night,
is
I
no
have to
option.
study. In night, I have to study. All of us have clothes or sweaters, particularly in dry weather. Have you ever tried to find an explanation for this phenomena? It can be attributed to electric charges, right? In this document, we will delve into the concepts of electric charges and fields, specifically focusing on their definitions, formula, properties, units, and more. Okay, so what is an electric charge? There is a topic one. Topic one, there is a uh, felt tipped open, right? Okay, what is an electric charge? Uh, Electric charge is a fundamental property of matter that determines how it interacts with other charged matter and electric fields, right? This property is carried by some atomic particles with protons carrying a positive charge, electrons a negative charge, and neutral particles having no charge, right? The word electricity comes from the Greek word electron, which there are two types of electric charges exist. First one is positive charge, second one is negative charge. What is positive charge? When an object has a positive charge, it means that it has more protons than electrons, right? Negative charge means when an object has a negative charge, it means that it has more electrons than protons. अब में समझ में क्या आता है? When there is an identical number of positive and negative charges, the negative and positive charges would cancel out each other and the object would become neutral, right? जितना पॉजिटिव है उतना ही अगर नेगेटिव है तो वो ऑब्जेक्ट न्यूट्रल हो जाएगा, राइट? ये आपको समझना है। अच्छा, हम लोग इलेक्ट्रिक चार्ज को मेजर कैसे कर सकते हैं, है ना? हाउ कैन वी मेजर एन इलेक्ट्रिक चार्ज? द इलेक्ट्रिक चार्ज इज मेजर्ड यूजिंग अ कूलॉम. 1 coulomb is the quantity of charge transferred in 1 second. Mathematically, the definition of a coulomb is represented as Q is equal to I multiplied by T, which is current multiplied by time. Okay, so in this equation, Q is the electric charge, I is the electric current, and T is the time. यूनिट क्या होती है भाई? यूनिट मैंने ऑलरेडी आपको बताया कि कोलॉम में हम लोग एसआई यूनिट मेजर करते हैं, ठीक है? इन प्रैक्टिस वी कैन अंडरस्टूड द मिली कोलॉम विच इज़ एम सी 10⁻³ कोलॉम, ठीक है? माइक्रो कोलॉम होता है 10⁻⁻⁶ और नैनो कोलॉम होता है 10⁻⁹ सी जी एस यूनिट में चार्ज जो होता है वो इलेक्ट्रोस्टैटिक यूनिट होती है जिसको ई एस यू के साथ भी लिखते हैं. एक गुलाम में 3 × 10⁹ ई एस यू चार्जेस होते हैं, राइट? डायमेंशनल फॉर्मूला होता है M0L0T1A1, राइट? अच्छा, चार्जेस चार्जेस ऑफ अ सिंगल इलेक्ट्रॉन आपको पता है -1.6 × 10⁻⁹ गुलाम. प्रोटॉन पे वही पॉजिटिव हो जाता है और न्यूट्रॉन पे जीरो, बिकॉज न्यूट्रल हो जाता है, न्यूट्रॉन तो न्यूट्रल होता है, राइट? अच्छा, एक क्वेश्चन आता है, क्या इलेक्ट्रिक चार्ज जो है एक वेक्टर क्वांटिटी है या नहीं? नो. इसका आंसर है नहीं. इलेक्ट्रिक चार्ज इज अ स्केलर क्वांटिटी. कैसे? Apart from having a magnitude and direction, for a quantity to be a termed a vector, which we will study in detail later, It should also obey the laws of vector addition, such as triangle law of vector addition and parallelogram law of vector addition. Only then the quantity is said to be a vector quantity. So that is why it is a scalar quantity. Imagine you have two charges. Q1 is equal to 4 coulomb, Q2 is equal to minus 2 coulomb. Right? When we combine these two charges, we can simply add them algebraically, which is equal Q total is equal to Q1 plus Q2, है ना. नेट चार्ज हमारे पास में फिर भी +2 बचेगा. राइट. We end up with a net positive charge. Notice that we only considered the numerical values and their signs, positive or negative charge, while adding. There was no need to consider any direction associated with the charges. This illustrates that charge is a scalar, but there is no direction at all. Now, which we comes on topic number 2, which is properties of electric charges, है ना. राइट. अच्छा, प्रॉपर्टीज कौन कौन सी होती हैं. फर्स्ट नंबर वन, लाइक चार्जेस रिपेल ईच अदर. लाइक मीन्स सेम चार्जेस, है ना. पॉजिटिव पॉजिटिव होगा तो रिपेल करेगा, और नेगेटिव नेगेटिव होगा तो भी रिपेल करेगा. Like charges repel each other and unlike charges attract each other. As you know, electric charge comes in two varieties which are called plus and minus, right? Electric charge is a scalar quantity, I told you before. It follows scalar laws of operations. That is, it adds algebraically and represents the excess of electrons in a negatively charged atom or a deficiency of electrons in a positively charged atom, right? Third one, it is a charge is transferable. Electric charge can be transferred from one body to another, but there is a restriction to the charge transfer. Only electrons are transferred from one body to another because protons are tightly bound to the nucleus of every atom. Hence, the body which loses electrons in the transfer becomes positively charged, and the body which receives electron becomes a negatively charged. Right? A neutral body has a number of electrons is equal to number of protons. A positively charged body has a number of electrons is less than number of protons. Third one, it is a negatively charged body has a number of electrons is greater than number of protons. ये हो सकता है, इक्वल हो सकते हैं, लेस हो सकते हैं और ज़्यादा हो सकते हैं. राइट. नेक्स्ट नंबर है, चार्ज इज ऑलवेज कंजर्व्ड. In an isolated system, the total charge, which is sum of positive and negative charge, remains constant. Whatever charge transfer takes place in the system internally. During this internal charge transfer, charges flow until they are eventually distributed, reaching a state of electrostatic equilibrium where is no further charge movement occurs without external influence. This is known as the principle of charge conservation. Right? Next one, it is the charge is quantized. It means charge on any body always exists in integral multiples of a fundamental unit of electric charge. This unit is equal to the magnitude of the charge. No one on one electron is equal to 1.6 multiplied 10 to the power minus 19 coulomb. So charge of anybody Q is equal to plus minus Ne, right? Number of electrons, where N is an integer and E is the charge on a single electron, right? This was proved by Millikan's oil drop experiment. Recently, the existence of particles of charge plus 2 by 3 electron and minus 1 by 3 electron has been postulated. These particles are called quarks. But still, this is not considered as a quantum of charge because these are unstable. They have a very short span of life, right? Charge is always associated with the mass, right? Yes. I'm telling you that electrons, protons, and neutrons also have masses. Their values determined experimentally to be following. You already know, I told you before, at the time, mass of electron is equal to 9.1 multiplied 10 to the power minus 31 kg. Right? In AMU, 5.49 multiplied 10 to the power minus 4. एक्चुअली मोस्ट ऑफ द टाइम हम लोग केजी में ही यूज़ करते हैं. मास ऑफ प्रोटॉन इज इक्वल टू 1.67 इंटू 10 की पावर माइनस 27 kg, which is in AMU 1.007 AMU, right? Mass of a neutron is equal to 1.6749 multiplied 10 की power minus 27 kg, but in AMU 1.008. It means mass of neutron is greater than mass of proton, likely. right? It is recommended to remember these values in kg, which is SI units. Also, please note that the mass of a neutron is slightly greater than the mass of proton, right? This also shows that the mass of a negatively charged body is greater than the mass of a positively charged identical body, as it would have an excess number of electrons than the positively charged bodies. Next property is the charge is relativistically invariant. It means it means that charge is independent of the frame of reference. That is, the charge on a body does not change whatever be its speed. This property is worth mentioning as in contrast to charge. The mass of a body depends on its speed and increases with the speed. You will be able to explore this party later when you will learn the special theory of relativity. Next important point is a charge at rest produces an only an electric field around itself. A charge at rest creates a region of fluence called an electric field around itself in space. While a charge having uniform motion, which is a constant velocity, produces electric and magnetic fields around itself. Accelerated charges produces a special combination of electric and magnetic field called electromagnetic waves. We will study in the upcoming section. Okay, some activities to understand charge. हम कट हो जाए. सबसे पहले हम लोग पढ़ेंगे बैलून्स अट्रैक्शन. बैलून्स क्या होता है? मान लेते हैं बैलून्स को फुलाते हैं, उसको रब करते हैं, करेक्ट, अपने हेयर में, या फिर किसी वोलन स्वेटर पे आप उसको रगड़ते हैं. देन होल्ड इट नियर स्मॉल बिट्स ऑफ पेपर or styrofoam. You will see that the balloon attracts these small objects, demonstrating the presence of static electricity, right? आपने देखा होगा. इसके अलावा salt and paper attraction भी आपने देखा होगा. Sprinkle salt and paper on a table, then rub a plastic comb through your hair. Hold the comb near the salt and paper and observe what happens. You will see that salt and pepper move towards the comb, demonstrating the attraction of opposite charges, right? लेमन बैटरी आपने देखी होगी, आपने एग्जाम्पल जरूर सुना होगा. कट अ लेमन इन हाफ एंड रिमूव द pulp, leaving only the skin intact. Insert a copper wire into one half of the lemon and a zinc wire into the other half. Then connect the wire using a small LED light. The lemon will generate enough electricity to light up the LED, demonstrating the production of electric charges. राइट. कॉम एंड स्मॉल पीसेस ऑफ पेपर आपने पढ़ा होगा, बहुत बचपन में हम लोग खेल खेलते हैं. सो रब अ प्लास्टिक कॉम अगेंस्ट अ वोलन क्लॉथ और फर and then hold the comb close to small pieces of paper or confetti. Observe as the pieces of paper are attracted to the comb and stick to it, demonstrating the presence of static electricity. Static electricity क्या होता है? I need water. Wait, I'm coming. दिन में सोए, दिन में मम्मी दिन में सोए थे, दिन में सोए थे तो मैं. Okay. So I'm telling about a static electricity. Static electricity refers to an imbalance between the electric charges in a body. specifically the imbalance between the negative and the positive charge on the body, right? The imbalance in the charge is introduced by physical means. One of the most common causes of static electricity is contact between solid objects. It was mentioned earlier that the movement of protons is not possible, and the only movement of electric charge seen in static electricity in electrons, right? Electrons as materials are held extremely loosely, meaning that they can be exchanged through simple contact like rubbing. The image below is an example of rubbing a glass rod with silk, which causes static electricity. When two objects are rubbed together to create static electricity, one object gives up electrons and becomes more positively charged, while the other material collects electrons and become more negatively charged, right? We should keep in mind that the rules such as like charges repel and unlike charges attract is applicable here, correct? Conductors and insulators, ये क्या होते हैं भाई, क्या बताएगा? बोलिए। टिंग 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 टिंग। Topic number 4 is conductor and insulators. Any object can be broadly classified into either of the following two categories on the basis of its electrical properties. Either it is conductors or insulators, right? Conductors क्या होते हैं? The materials or substances that allows electricity to flow through them are called conductors. Conductors are able to conduct electricity because they allow electrons to flow inside them very easily. The general property of a conductor is to allow the transition of heat or light from one sources to another. Metals, humans, earths, animals, bodies fall in the category of conductors, but may sometimes contain nonmetals too. For example, carbon in the form of graphite, right? Conductors have free electrons on their free surfaces, which allows current to pass through. That's why conductors are able to conduct electricity. We can use conductor in lightening to a bulb, right? Conductors are quite useful in many ways and are used in many real life applications like mercury is used in a thermometer to measure the temperature of a body. Aluminium is used in making foils to store food and also in the production of frying pans to store heat quickly. देखा होगा आपने एल्यूमिनियम के जो फ्राइंग पैन होते हैं ना. Iron is used in a vehicle engine to the conduct heat. The sole plate of an iron is made up of the steel and to absorb heat briskly. Conductors are used in a car radiators to dissipate heat away from the engine. करेक्ट, ये सब चीज़ें कंडक्टर्स होते हैं. इंसुलेटर क्या होता है भाई? The materials or substances that resist or don't allow the current to flow through them are called insulators. Insulators are mostly solid in nature and are used in variety of systems. Most insulators also resist the flow of heat. The property which makes insulator different from conductors is its resistivity. Wood, cloth, glass, mica, and quartz are some good examples of insulators. Insulators are also called protectors as they give protection against heat, sound, and of course, passage of electricity. Insulators don't have free electrons, and that's why insulators don't conduct electricity. For example, glass is the best insulator as it has the highest resistivity. Plastic is a good insulator and is used in making number of things. Rubber, which is used to make tires, fire resistance, clothes, and slipper, is a very good insulator, right? एप्लीकेशन ऑफ इंसुलेटर्स क्या क्या होते हैं? Being resistance to flow of electron, insulator are used worldwide in a number of ways. First one, thermal insulators. This allow heat to move from one place to another and is used in making thermoplastic bottles, in fireproofing ceilings and walls. Sound insulators help in controlling noise levels, as they are good at absorbing sound, are used in buildings and conference halls to make them noise free. Electrical insulators, which hinders flow of electron or passage of current through them, are extensively used in circuit boards, high voltage system, and also in coating electric wire and cable. Concept based question, which are topic number 5. Topic number 5 is topic based question. So question number 1, which is first, उसके पहले मैं पूछता हूँ, why have we defined only two types of charges? Why not three or four? क्यों दो प्रकार के ही चार्जेस होते हैं, तीन नहीं? रीज़न क्या है? Only two kinds of electric charges exist because any unknown charge that is found experimentally to be attracted to a positive charge is also repelled by a negative charge. No one has ever observed a charged object that is repelled by both a positive and negative charge. No one has ever observed. You know what it means? Wow. when two charge when two like charges are brought together, जब दो सेम चार्जेस को एक साथ लेकर आया जाता है तो क्या होता है? When two like charges are brought together, they repel each other with an electrostatic force. अगर दो हम अनलाइक चार्जेस को लेकर के आए साथ में तब क्या होता है? So when two unlike charges are brought together, right? Unlike मतलब opposite charge. When two unlike charges are brought together, they attract each other with an electrostatic force. You understood what I'm saying? You should. Question number 3 क्या कहता है? What does neutral and electric charges mean? Neutral क्या होता है? Right? Neutral does not refer to any third type of charge. It is the absence of any excess or deficiency of electrons in the body. That is, the number of electrons is equal to number of protons. Right? The number of electrons is the number of protons. Okay. So question number 4 क्या कह रहा है? Does the mass of the body get affected while charging? क्या क्या बॉडी का मास अफेक्ट करता है चार्जिंग के समय? Yes. The mass of the body gets affected because electrons have a definite mass. मैंने अभी आपको बताया था इलेक्ट्रॉन का अपना खुद का मास होता है. So the mass of the body slightly increases when it gains electrons while the mass decreases when it loses electrons. अगर कोई भी बॉडी कोई भी ऑब्जेक्ट अगर इलेक्ट्रॉन गेन कर रहा है तो उसका मास डेफिनेटली बढ़ेगा और लूज कर रहा है तो उसका मास डेफिनेटली कम हो जाएगा. टू आइडेंटिकल मेटेलिक स्फीयर्स ऑफ एग्जैक्टली इक्वल मासेस आर टेकन. ठीक है, दो ऐसे मेटेलिक स्फीयर को लिया गया जिनके मासेस इक्वल हैं. वन इज गिवन ए पॉजिटिव चार्ज q कूलम एंड द अदर इज इक्वल नेगेटिव चार्ज. ठीक है, एक पॉजिटिव है और एक नेगेटिव है, दोनों के मासेस सेम हैं. राइट? आर देयर मासेस आफ्टर चार्जिंग इक्वल? अब बताइए भाई. अगर हम उनके चार्ज को इक्वल कर दें तो क्या होगा? चार्जिंग के बाद उनके मासेस क्या होंगे? तो भाई नहीं होंगे. No, a body is positively charged due to the deficit of electrons, while the negatively charged is due to the surplus of electrons. Hence, the mass of the negatively charged sphere will be slightly more than that of a positively charged sphere. Right? Now, question number 6. क्या कह रहा है? समझो. During a nuclear reaction, what happens to electric charge? न्यूक्लियर रिएक्शन के दौरान इलेक्ट्रिक चार्ज के साथ में क्या होता है? In the event of a nuclear reaction, the electric charge is conserved considering an isolated system. This is true for any nuclear or chemical reaction. In a nuclear reaction, the parent nuclei undergo a transformation into a daughter nuclei, but the total algebraic charge remains constant. So, टोटल एल्जेब्रिक चार्ज जो होता है वो कांस्टेंट रहता है, कुछ भी घटता या बढ़ता नहीं है. ठीक है. एंड द लास्ट क्वेश्चन इज एक्सप्लेन द स्टेटमेंट फॉर अ बॉडी एंड इलेक्ट्रिक चार्ज इज क्वांटाइज्ड. एक बॉडी के लिए जो है इलेक्ट्रिक चार्ज क्वांटाइज हो सकता है. ये क्या कहना चाह रहा है? ये बताता है द नंबर ऑफ इलेक्ट्रॉन्स विच कैन बी ट्रांसफर्ड फ्रॉम दैट बॉडी टू अनदर, कि हम लोग एक बॉडी से नंबर ऑफ इलेक्ट्रॉन्स को ट्रांसफ़र कर सकते हैं. इट शुड बी नोटेड दैट चार्जेस डोंट गेट ट्रांसपोर्टेड इन फ्रैक्शन. इसका मतलब ये है कि जो चार्ज होते हैं वो फ्रैक्शन में ट्रांसपोर्ट नहीं किए जाते. So therefore, the overall charge on a body is simply an integral multiple of charge on an electron. उनके मल्टीप्लायर में ही वो इससे उधर चार्जेस हो सकते हैं. राइट. सो टुडे इज द लास्ट question of the day. I hope you enjoyed well, get a good knowledge, and I'll see you soon with another topic. Our next topic will be the charging by induction. Correct. चार्जिंग ऑफ बॉडी हम लोगों का नया टॉपिक होगा, जो कि कल हम लोग मिलेंगे लगभग 11 बजे के आसपास. टिल देन गुड नाइट, शब खैर. आई होप आप सब ने एंजॉय किया होगा.